Hello everyone and welcome to Vibrations in Acoustics. Today we're going to find the equivalent spring constant for a system of a couple of pulleys here. Alrighty, so when you're first looking at a system like this, usually it's best to kind of break it down into pieces and try to find the displacements of both of the springs. And from the displacement you can get the force that's applied and everything else. So we're going to start by basically summing the forces on each one of these pulleys and figuring out what we've got. So what we're going to do is take the first pulley right here, and we've got two forces coming up on it, which are both from, actually, I'm going to start a little bit backwards here. I'm going to look at the mass first. So the mass has a weight equal to mg on it, but then it also has some force equal to the weight, which we'll call KEQ times dx. But we don't know what this x is, and we need to figure that out in order to continue on. So now I'm going to move to this pulley and do a line up on it. Weight, because since the weight is just directly transferred along this line, it pulls down with some weight right here, but then on the opposite side it's also pulling down with some weight in order to create an equivalent system, some of the forces. So we've got weight, and then we've got K2, X2. Alrighty then. So that's pretty good. And then we know that this is going to displace down some amount, we'll call it x2. And then it'll be right here. So as soon as the weight is basically let go, this pulley is going to displace down some distance x2. All right, now looking over at this pulley, this one right here, again, since the weight directly transfers along this line, you've got weight right here and weight right here. And then you've got a K1, X1. And again, it's going to displace this direction, x1, and then you'll end up with something like there as soon as the weight is released again. So using the equation for force of a spring, or just equating these two forces, K1 x1 is equal to 2w, which is pretty easy. So then x1 is equal to 2w all over K1. Alrighty, and then going back here to this one, K2 x2 is equal to 2w, which is the sum of the forces. x2 is then equal to 2w all over k2. Alrighty then, so now we need to figure out what the displacement of this will be. Well, let's look at it. If this pulley displaces some amount, I'm actually going to redraw another picture here and make a comment about it. If you've got a pulley and you've got a rope going around it, you're going to have, if it displaces some direction x, then you're going to end up, I'm going to draw this rope as if it's still in the same location, but the pulley has moved up. The pulley has moved up. So you begin right here where the rope is touching with the pulley, but then the pulley moves up to right here basically. What you've done is you've just cut off two sections of rope basically that need to go somewhere. These two little bits of slack from the pulley moving up in order to get it to right here is double the distance that you move. So if this is x, then the rope is going to change length by 2x. So this is going to be y. This is now going to become y plus 2x. And this is going to be over here on this side. If the rope is going this direction, rope is traveling this direction, then this is going to be y minus 2x. So that's how you figure out the displacement, or how much rope is given off by a pulley. A pulley that moves some distance gives out twice as much rope as the distance that it moves. So looking at this, we have this pulley moving some direction, which is going to give us, so the displacement of m is going to be, which we're going to call x, is going to be 2 times x1, because this pulley moves up and gives a slack twice of the distance it moves up, plus 2 times x2, because this pulley moves down and gives slack of twice as much as it moves down. Okay, so then you've got x is equal to 2 of x1 plus x2. So there's the rationale behind that. Okay, so now we have all these displacements x, excuse me, we can put them into an equation now that we can actually use. So I'm going to look at the force equation again. F is equal to kx. Okay. We know x. This is in relation to the mass, relation to mass, relation to mass. So this is basically weight equal to KEQX. If we're looking at the mass, which is the point where the displacement is occurring. So we have all of these values, we just have to substitute them in now. So since we have the x values for displacement, the total x value, we're just going to go ahead and go like that. So weight over KEQ is equal to 2, since we're using this equation and we're substituting in x1 and x2, 2 times x1 plus x2, which is going to be 2w over k1 plus 2w over k2, which is then equal to 4w of 1 over k1 plus 1 over k2. Okay, so now if we solve this out just a little bit further, you can get 1 over KEQ is equal to, divide by w here, 4 times 1 over k1 plus 1 over k2. And you can basically stop right here, because if you had numbers, you could substitute them in. But if you really want to solve for KEQ, what you'll end up with, I don't want to show all the algebra right here, you'll get 1 k1, k2, all over 4 times k1 plus k2. Which makes sense because these pulleys, the way they're behaving is, never mind, I'm not going to make that statement. That's not going to be okay. That's not a very good way of explaining it. Alrighty, so that is your KEQ. What you do is you get basically the sum of the forces for each part of the system, and you try to get the displacement of the part you're interested in, so basically the mass. And then you take the mass as an equation where you've got basically a simple system of a mass with a spring on it, and so which gives you a force of KEQX, basically this deal up here. Set that up in an equation, and then substitute in the values that you found, and that will give you your KEQ. So that's basically a force method.